What's up everybody, welcome back. So part 6 of our AI guard, and we're finally gonna start working on the behavior tree and the blackboard in this episode. So the first thing I want to do is set up the idle state inside of the behavior tree. So we're gonna make sure that we play random idle animations to make the AI look a bit more alive. And then we're also gonna move the awareness stuff to the actual behavior tree. So the investigating of the location from the spotted actor will be handled by the behavior tree. So that's today's episode. If you like the series, please consider leaving a like. And if you want to get the project files for yourself to download, you can become a YouTube member or a Patreon, and then you will get access to premium channels in the Discord that will also give you access to a download. If you don't want to become a member, still check out the Discord. There's also a ton of free downloads in there. And you can ask questions about videos or talk with like-minded individuals. So that's all of the stuff I got for you guys today. Let's dive into today's video. As I mentioned, I want to start with the idle state because that's also a pretty simple state. There's not a whole lot going on in there. So then we can get everything set up properly. Now the first thing we want to do is make sure that we have montages to actually play. So we're going to change the animations that we have into montages. And there's actually two idle break animations in here. One where he's looking around and the other one where he's fiddling with his weapon a little bit. So we're going to use both of those. So what we can do is simply select both of them, right click, then go to create, and we want to create an animation montage. So it will simply create both of them. If we hit enter, we want to open them up and make sure that we set up the correct slot in here. So we could use the default slot, but I want to expand this later a little bit. So let's make sure we have a slot named that is properly. So we're going to go to the animation slot manager, and if you don't have this window, you can go to Windows over here and then look for the animation slot manager and simply open it from here. And in here we want to add a slot, so simply click add slot, and let's call this full body. So we're going to use this slot for all of the full body animations. And after we added it in here, we can go to the slot over here and then assign the slot name and change it to full body. So he will go in the A pose. Nothing is really broken. If we simply drag the bar a little bit, he will start playing the animation again. I don't think we need to do that. It's just a visual thing. And so we want to do the same for both of the animations. Now that we have the slot in place, we don't need to create it again. So we can simply go to the slot and then assign our full body slot for this montage as well. So those are the montages. Because we are playing them in a slot, we need to go to our animation blueprint and make sure that in the animation graph we actually enter a slot node. So let's go to the animation graph, and this is a full body animation. So for this one, I'm simply going to play it all the way at the end, and it's going to override all of the previous nodes in the animation graph. So before the output pose, I'm simply going to add a slot node. And it's called default slot by default, but if we add this and then have it selected, we can change the slot over here. So we're going to set it to the full body slot, and this will make sure that if we play the idle break montages, they will be inserted through this slot node. So compile and save. That's the montages and the animation blueprint setup. Now we want to use our interface to actually trigger the idle animations. So let's go to our interface for the AI pawn. So that's in the behavior folder, AI pawn interface. In here we're going to add one function, and I'm going to call this trigger idle break animation. So trigger idle break anim, and I'm going to give this one input over here, and that's going to be the index. So let's simply call this index and then turn it into an integer. So I'm going to set it up. If we actually specify an index, we're going to play a specific animation. If we set the index to -1, we pick a random one. So that's the blueprint function. That's set up and good to go. So now we need to actually set this one up inside of our card. So we want to open our AI card character. And in here, we're going to use a rep notify, and we're also going to use a normal replicated variable. So let's create both of them, and I'll explain why I want to do it like that. So first of all, let's create an integer, and that's the idle break variation. So that's an integer, and this one is going to be normally replicated. And then we're going to add a second one, and that's our trigger idle break animation. So this one is going to be a boolean, and we want to make sure we set the boolean to be a rep notify variable, so we can use it instead of a multicast event. Now, the idle break variation is going to be used to determine which animation or montage we're playing, but if we would simply make this a rep notify variable to use it to trigger the actual animation, it will not fire if we play the same animation twice. So a rep notify will only fire if the variable actually changes. So if it goes from true to false, or from 0 to 1 or whatever, that's good. If we want to play the same animation twice, so we have the same index, the variable doesn't change, and the notify event will not fire for client. So we're going to simply use a boolean to trigger the animations and the break variation index to determine what montage or animation we're playing. So we added the interface event, and we want to add it to our character. So let's double click it over here. And then we can switch on the integer over here. So switch on int. With the switch node selected, we want to set the start index to -1. And then I'm going to add pins for -1, 0, and 1. So if we want to play a random idle variation, we're going to drag in the integer, plug it into the -1 pin. And for this, we can simply hook up a random boolean. So if we right click and look for a random bool, so this is true or false. And if we drag off here and do to integer, then we can convert a bool to an integer. So false will be 0 and 1 will be true. So we can simply use that to drive our integer over here. We could also hook up the default pin in case we use different values that don't exist. So let's do that. And then for the 0 and the 1 pin, I'm simply going to paste the setter and then assign either index 0 or index 1. So plug them in over here and then simply set them up manually. And after we set the correct index, we want to fire our rep notify. So we're going to grab a setter for the trigger idle animation boolean. And then we also want to grab a getter, and we're simply going to flip it around. So if we drag off here and look for a not boolean, it will make sure that true becomes false and vice versa, and then save it again. So this will make sure the variable always changes, and for that reason, it will always fire for clients. So we need to make sure that we set up the onRep function. That's the function that will actually fire if we trigger the rep notify event. And in here we can simply play an animation montage. So if we drag off here and look for play, nope, I don't know what button I hit, play anim montage. So because we are inside of a function, we cannot use the normal latent node, but that doesn't really matter. We can simply use this one. And for the animation montage, we can drag off here and do select, like so. And then for the index, we can plug in our idle break variation. And then if the index is 0, he will select this animation montage. And if it's 1, he will select this one. So we can simply select idle break 1 and idle break 2 in here. That should be good to go. And that's the setup that we need on the character. So now finally it's time to create our BlackBoard and behavior tree. So let's go inside of the behavior folder. I'm gonna store all of the behavior stuff in here. The first thing I want to create is a BlackBoard. So let's right click, go to artificial intelligence and create a blackboard. So let's call this my blackboard game dev raw guard, for example, AI guard, why not? And let's also create the behavior tree. So right click, artificial intelligence, and then behavior tree. So this is my BT, game dev raw AI guard. Now a blackboard and a behavior tree go hand in hand. So you cannot have a functioning behavior tree without a blackboard, and a blackboard doesn't do anything if there's no behavior tree. So if we open up our behavior tree and expand it over here, you will see it automatically assigned our blackboard to this behavior tree because we only have one blackboard in this project. Otherwise, you need to make sure in here you have the correct blackboard assigned. And then at the top right, you can use these buttons to switch between your behavior tree and your blackboard. A blackboard is really just a board with all kinds of variables that you can set from the controller without having an actual reference to them. And then that will drive the behavior tree. So we're simply using all of the variables on the blackboard to feed into the behavior tree, and the behavior tree will respond to that. So that's how those relate to each other. We're going to start setting up the blackboard by adding a variable in here. And that's going to be our current state. So that's going to be our AI state enumeration. So over here we can go to new keys and then add an enumeration. Let's call this our current state. And now it's simply set up as an enum, and we want to make sure it's our AI enum. So if we go to key type over here, we can specify the enum type, and that's our AI states enumeration. And then over here is the actual name of the variable that we used. So this is called the blackboard key. And if we want to change this variable on the blackboard, we need to refer to this key. So it's important that we either remember this and also that these names make sense, so they are easy to remember as well. So with the current state in place, we want to go to our behavior tree and then do a little bit of setup in here. So I might want to do a little bit of explaining as well. Behavior tree is kind of like a flow tree. So we can add all kinds of different nodes, and they will have different behavior, obviously, and using that we can determine how it flows. So let's just start really simple. If we drag off the root, this is where everything starts, and we can add either a selector, a sequence, or a parallel. So you'll mostly be using the selector and the sequence, and they're pretty much each other opposite. So if we look for a selector node executes their children from left to right and will stop when one of their children succeeds. And if we go to a sequence, that's the exact opposite. So it will execute from left to right and will stop when one of the children fails. And then the second part, if a child fails, the sequence fails. So the entire node over here fails. If all of the children succeeds, then this node succeeds as well. And that's the same thing over here, only the opposite. So you can use these to control the flow inside of the behavior tree, and you can also add decorators, which are conditions or other stuff that you want to do in here to determine if you need to execute this state or not. So let's just slowly start building it, and it will become a bit more clear probably. So what we want to do in here is we're going to start with an actual sequence node. So let's get rid of the selector. Let me see. Yeah, that should be fine. So over here, we're going to add a check later to determine if our AI character is still alive or not. So right now, we're not going to use this sequence node, but let's just make sure we have it in place. Then we're going to drag off here, and from here, we're going to add a selector. And we're going to use this selector to set up our idle state. So if we right click on the selector, we can go to add a decorator and then select blackboard. select this decorator that we just created, and this is going to be a condition that will determine if this node will fire or not. So if we have it selected over here, we can change the BlackBoard key to our to our AI state. And then it will show up here, and we can set the actual condition that we want to use. So is equal to, is not equal, is less, is greater, because an enumeration is a byte or a number, basically. So what we want to do in here is check if our current state is equal to idle. So that's already in here, that's good. And we're also going to make sure that on result change, we're going to abort ourselves. So this will make sure that if the idle state changes and the result of this check changes, so not necessarily the key value, but if the result changes, everything that's running down here will be aborted and things will be re-evaluated. So we have the selector node over here. If our current state is idle, we want to wait for a random time. So we're going to drag off here, go to tasks, and in here we have all kinds of default tasks that we can use. Now there is a little side note, we are using this in multiplayer, and most of these are not set up for multiplayer. So for example, if we use the play animation node, it will only fire on the server. So most of these aren't really useful, but some are. And right now we simply want to add a wait in here, so we're not constantly playing an idle animation, but only every so often. And then we can also adjust this wait a little bit to have random deviation, so it's even more random. So for now, I'm simply going to set the wait time to say 7 seconds and then add or subtract 1, so it could be 6, 7, or 8. You probably want to extend this in an actual game, but for now, for testing, this is good, so we can actually see something happening pretty quickly. And then we actually want to play the montage over here. Now, as I mentioned, we have these default tasks, and those aren't really useful, so the play animation doesn't work in our case. We need to make sure that we fire everything in our multicast, or actually wrap notify event, so it actually works for clients as well. So what we can do is create a task of our own and then make sure that that's actually set up for multiplayer. So we're going to go over here to the top and create a new task. It will show this window, and I want to put these tasks in a separate folder. So first of all, I'm going to create a new folder. And let's call this my behavior tree tasks, so BTT. And inside I'm going to create the new task, so that's the behavior tree task. And then let's call this play idle break. And it will open it up for us immediately. Now what we want to do in here, we can go to the override section and you will see different events you can override. So we have an execute and an execute AI. Obviously, we're working with AI and AI controllers, so we want to use the execute AI. If we're working with players, you want to use the normal execute one. And then you have something to also respond to aborting the task, and we have a tick function in here. We're not going to use that right away. In this case, we want to add our receive execute AI event. And this will immediately give us a reference to both the controller and the controlled pawn. So we actually have something to work with in here. And we also want to add a variable to make sure that we can set everything up correctly. So we're going to add one variable and call this our animation index. Turn this into an integer, and then we want to make sure we set it to instance editable so we can change it. Then we can simply drag off our controlled pawn and call the interface function that we created to trigger the idle animation. So that's trigger idle break animation, the message function from the interface. In here we can plug in our animation index. So if we set this index to -1, we're playing a random animation, and otherwise we can specify which one we want to play. And that's really all we need to do in here. Now, an important thing with tasks is that you need to finish them with a finish execute node. So you want to look for a finish, and then you can either do finish execute if this was completed, or finish abort if the task is aborted before it's actually done. So we're going to use finish execute, and then over here we have a boolean that will return if it was successful or not. And that actually relates back to the selector and the sequence nodes. So you can use those to determine the flow as well. So we need to make sure that this will succeed if we want to make sure that our selector keeps executing the children connected to it. Now in this case, this is not too important because this is the last node that we're going to add to this selector. But it's important to know that this node, this boolean actually controls the flow of the selectors and the sequence. So we're simply going to set it to successful, and that should be good to go. So if we call this task, it should play the idle animation on our character. And after we created it, we can simply drag off, go to tasks, and our custom task is in here. So we're going to play an idle break animation. So this should pretty much be good to go, and this aborts itself. Yes, so that's good as well. Now all we need to do is make sure that our AI is actually using this behavior tree and this BlackBoard. So let's open our AI controller. Yes, the controller, not the character. And in here we have our event on possess. So currently we're storing just our possessed pawn in here, and we're going to drag off and run a behavior tree. And then we can simply select the tree that we want to run. So we only have one, and we're going to assign that over here. Compile and save it. So now the behavior tree should be assigned, and when the AI is in aware, he should play random idle animations. So let's have a look if this is working, and let's do it multiplayer, why not? So we can see both the host and the client. So this shouldn't take too long for an animation to start playing. And it's actually taking a bit too long. So is it working server side? No, it's also not working server side. So we can use our gameplay debugger. If we hit the correct key to open the debugger, the behavior tree category is actually activated. So you can see it's currently having the current state idle on the BlackBoard. So that's correct. And on the left side, it's hanging on the wait node. So I'm going to check out what's wrong. The behavior tree does seem to fire, so I don't think the problem is in there. I'll be back in a sec. Okay, that's my bad. And this actually points out how confusing a behavior tree can be. But this is also because my behavior tree in the example project looks a lot different, and I kind of switched up a few nodes. So we have the selector over here, and the selector executes from left to right and will stop when one of the children succeeds, and the wait will succeed always. So it will wait, this will succeed, it will abort, and then start over and wait again. So it will never reach the play idle break. So what we want to do is change this selector into a sequence. That's my bad. This selector later will actually contain the check for the dead actor, and then below here we're going to have a sequence, and we can move the condition to the sequence like so, and then make sure these nodes are hooked up to the actual sequence. And then we can get rid of the first sequence in here, to be honest, and hook it up over here. So we have a root, a selector. Later we're going to add an isAlive check over here. After the selector we have a sequence, and the sequence is the actual idle sequence. So this should work, and now if we play this, we should have random idle animations. And as you can see, it's playing a random animation, and it's working for both the host and the client, and it's also playing the same animation, so the index is the same. So that part is replicating, and we have a very basic start of our behavior tree. Now I want to take a look at setting up the aware state in the behavior tree as well. So the moving towards the investigation location, investigating the location, all that kind of stuff, we're going to handle that inside of the behavior tree. So let's have a look at the aware state now. If we are playing a montage, we need to make sure that we can actually stop that montage and then trigger something else. Otherwise, it will first finish playing the montage before it starts doing something. So we need to set that up, and we're going to use our interface for that. The BPI card interface for the character. So we're going to go to the behavior folder and open the AI pawn interface. And in here, we're going to add a function called stop all montages. So we don't need any inputs or outputs. We can compile and save and get rid of this. So if we go to the guard, we want to implement it. So let's open our guard character. And first of all, let's add the actual interface event. So let's double click stop all montages. And again, for this, we're going to use a boolean that's set to a rep notify variable. So we cannot duplicate this one because it will not generate the function and things like that. So we simply need to create a new variable and call this trigger stop montages. Trigger stop montages. No, really. So we're going to turn this into a rep notify as well. And then in here, we're simply going to set it and then get it and flip it around. So it will change each time we set it. And then the event will fire, or the function. So we're going to open the function, stop all montages. And what we want to do in here is simply call a node called stop animation montage. Oh, really? And if we don't plug anything in here, it will simply stop the current montage that is playing. So this is all we need for now. Let's compile and save that part. And then we want to go to the AI controller. And inside of the AI controller, we want to make sure that we set the value on our BlackBoard. So we have the current state value on our controller. And if we change this value, the behavior changes. And we also added this value to our BlackBoard, and we want to update it if we change the state. So first of all, for example, let's go to the start combat state. This is the game mode event. I made this a little bit of a mess, I think. So here we are, start combat state. Let's move this over here. And then this as well. So these are all state events. There we go. So if we start combat, we want to make sure that this value on the BlackBoard also updates. And this is kind of where we also meet the power of a BlackBoard. We don't need to cast to any kind of specific BlackBoard or get any references. We can simply set values on a BlackBoard by referencing their name. So the first thing we can do if we're on a controller is simply get a BlackBoard. So this is a default variable that's always present on the AI controller. And from here we can drag off and we can set a value. And then we have all different value types that we can set. So we want to set a value as an enumeration. And then this works with the byte enum, but we can simply plug in our normal enum and it will convert the enum into a byte. So simply plugging it in, that will work. Now for the key name, we want to drag off and make a literal name. So we can simply type in a name. You can also promote it to a variable and then assign the name as a default, whatever you want. So this name needs to refer to the name on our BlackBoard. So if we open our BlackBoard, the current state, that's the value that we want to change. So I'm simply going to copy it from here and then paste it in here. So this will change the current state value on our BlackBoard into combat. So let's hook that up over here and then hook it back up to the interface call. So we can copy these nodes, and we want to do the same thing if we trigger the aware state. So then we also want to update the state to aware on our BlackBoard. So right after we set it over here, let's paste in the nodes. And we don't need to change anything because we're simply grabbing the value and it's the same variable, so that's good to go. Now that we have this stuff in place, we want to go into our behavior tree and make sure that we actually have our, no, that doesn't work. So we need to open the behavior tree, that we have our stop animation montages function working. And we need to create a task for that to actually make that work. So let me grab my notes in here quickly. So we're going to create a new task again, and this time we can select either our previously created task, but we don't want to do that. We simply want to create a new clean task. So we're going to select the lower one. I'm going to store it in this folder and then call this my behavior tree task stop all montages. So again, we need to set up the event. So we're going to use receive execute AI again. And in this case, we can simply call our interface function. So we want to drag off the pawn because the interface is on the pawn. And then call stop all montages, the message function from the interface. And because this is a task we're executing on our behavior tree, we need to finish this with a finish execute node. And we're simply going to set this to a success. So this will make sure that our sequence will keep running because this task succeeded. So compile and save. Then let's go back into our behavior tree. And we're going to add a second branch to our selector over here. Let me make sure I'm not screwing up again. So let me double check. Yeah, we're going to add it to our selector. So a behavior tree always executes from top to bottom and then from left to right. And it will also add a little number over here to the node so you can see the actual execution order. So if we drag off here, we can add another composite and we're going to make this a sequence again. And because this is a selector, it will stop executing when one of its children succeeds. And if this fails, so if my current state is not idle, it will continue executing. So if my current state is not idle, he will check the next node. And in here, we're going to check if our current state is aware. I'll get back to the rest later. So let's go to this sequence node. In here, we're also going to add a decorator, and that's a BlackBoard key again. Select this, and in this case, we want to check our current state is equal to aware. And again, we want to make sure that this aborts itself. So if the state changes and the outcome of this condition is different, then this will abort what we put below here. And what we're going to put below here is really simple. We're simply going to call our task to stop all montages, like so. And for now, we're going to add a wait in here. So at the end, you usually want a little wait to make sure that this is not running on tick and firing really fast. So let's just put a wait in here and we'll expand from here later. So we have the behavior tree set up, and now we can go into our BlackBoard. And in here, we're going to add our spotted actor location. So that's the location that we're going to investigate. So let's add a new key, and that's going to be a vector. We're going to call this our spotted actor location. And we want to set this from our controller again. So we're going to go back to our AI controller. And in here we have the AI move to node. So we are in the start aware state event. And we're going to move this part to the behavior tree as well, so we can get rid of the AI move to node. And before we continue, our possessed pawn over here is a pawn, and that was because we need to plug in a pawn over here. But we're only using this reference to fire interface calls, and for an interface, we don't need to save it as a pawn. We can save it as an actor or even as an object. And the lighter the reference is that you pick to save, the less intensive it will be for the memory. So in this case, we don't need our possessed pawn to actually be a pawn variable. So if we delete this move to node, we can go to the pawn and simply change it into an actor. So we have a lighter reference. So let's change variable type, and that shouldn't break anything because these are simply interface calls and they will keep working. So with that little side note, we want to set up the actual move to on our behavior tree. And for that, we're going to set the spotted actor location on our BlackBoard. So let's grab the BlackBoard variable again, right click and get BlackBoard. So this time we want to set a value, but we want to set a value as a vector. So that's the spotted actor location. We're going to plug this in over here. The value is the location returning from the get last perceived location. And then we want to make a literal name again, so we can specify our spotted actor location. And I'm simply going to copy that from here and then paste it in here. And after that, we actually want to change our current state. So we want to make sure that this node that we added, we want to move it to the back over here. So first we set the location, then we change the state, and the state will make sure we use this location to investigate. So we need to set it in this order, like so. Okay, this is a little bit messy. That's fine. Okay, now let's see if we go inside of our behavior tree. Let's tie this together. So let's go back to our behavior tree. And in here, let me see. We can simply expand it over here. So before we wait, we can drag off and go to a task. And we can move to a location, and this task actually works. So we can simply use move to, and we don't need to worry about replicating this ourselves. So we can select the node over here, and then we can change the BlackBoard key into our spotted actor location. So it will use the location that we set on there. And I think all of the other defaults should be good. Yeah, that's all fine. And the acceptance radius should be good as well. So now, instead of using the move to node, it should move our behavior tree node. So let's test this. Let's do a single player first, and I'm going to keep the behavior tree open as well. And then you can see it actually is running on the side. So let me hit play over here. And then switch to my behavior tree. So you can see it's actually executing this wait right now, and you can see what is active and what's not. And if a condition fails, it will have a red mark over here as well. So that's always useful for debugging. So if we move towards the AI, then he will start spotting us, and as soon as the bar filled, he should set the spotted actor location and then move towards that location. So that's actually working, and you can see in the bottom right of the screen the current values that are stored on the BlackBoard. So you can also see those are updating and changing, so the current state is aware and the spotted actor location is actually set. So all kinds of useful stuff to actually keep track of what's working. And as I mentioned at the start of the video, you also have the gameplay debugger with a special behavior tree category displaying the behavior tree and all of the BlackBoard values and all of that stuff. There is one small side note I keep forget to mention about the gameplay debugger, by the way. For me, sometimes, and I don't know what's triggering it, it stops my prints from appearing. So after I use the gameplay debugger, none of the prints I actually used in print string nodes will appear. So I have to close down the editor and restart the project, and that will usually fix it. Sometimes I have to actually remove all of the local saved files, and then it will go back to printing again. So Gameplay Debugger, very cool tool and very useful, but the fact that it can break your print strings, that's not cool. So just a little side note, keep in mind that's something that can happen to you as well, maybe. So we started our behavior tree, and we're going to keep expanding this in the next episode, and we're also going to start setting up EQS in the next episode. So if you're not sure, EQS stands for Environmental Query System, so we can use it to get information from the world around us to determine locations in the level or actors in the level, things like that. So that's a pretty useful and also pretty fun tool to work with. Okay, so that was today's episode. Hope you enjoyed it. If you did, please consider leaving a like, and I'll be back soon for more. Later, guys and girls. Bye bye.